We have discussed about chemical equilibrium. Now let us move on to ionic equilibrium. Ionic equilibrium is shown by electrolytes in solution. We have got two types of electrolytes, strong electrolytes and weak electrolytes. Strong electrolyte is one that dissociate completely when dissolved in water, like NaCl, KCl. Weak electrolyte is one which does not dissociate completely. So naturally, the chapter of equilibrium will deal only with weak electrolytes and not with strong electrolytes. Let us consider a weak electrolyte AB which dissociates to give us A ions and the B ions. Suppose the concentration of AB is C moles per liter and alpha is its degree of dissociation. By degree of dissociation we mean out of 1 how much has dissociated. For example, the degree of dissociation of a particular electrolyte is 0.25. It means out of 1 mole only 0.25 mole dissociates. Then K, equilibrium constant, can be written as the concentration of A into B upon AB. That is, say, C alpha into C alpha upon C into 1 minus alpha. As it is a weak electrolyte, the value of alpha will be very, very small as compared to 1. Hence, we can write 1 minus alpha nearly equal to 1. So, the expression comes out to be K is equal to C alpha ka square. Or alpha square is equal to K upon C, or alpha is equal to K upon C under the root. This expression is known as Ostwald dilution law. So from this expression it is clear that lesser the concentration, greater will be the degree of dissociation. That is to say, on dilution the degree of dissociation increases. The degree of dissociation is depends upon K. It means higher the value of K, greater will be the degree of dissociation. So if you are given a question where the value of K is given, in one case 10 to the power minus 2, 10 to the power minus 3, 10 to the power minus 4, 10 to the power minus 5, then he can ask which of these is a strong electrolyte? Naturally, one which has higher value of K, that is say first. Or he can ask which will dissociate to the minimum possible extent? Naturally, one which has the minimum value of K, that is to say the answer will be fourth. Look at the question. What is the concentration of acetate ion in 0.1 molar aqueous acetic acid solution? Ka is given to you. So while solving these questions, let us write the dissociation of acetic acid. Now its concentration which is given to you is 0.1. Suppose alpha is the degree of dissociation. So acetate ion will be 0.1 alpha. Hydronium ions will also be 0.1 alpha. Now K will be equal to C alpha ka square, or he is asking the concentration of hydronium ions. So concentration of acetate ions. The concentration of acetate ion is equal to C alpha is equal to 0.1 into alpha. Now alpha is K upon C under the root 1.8 into 10 to the power minus 5 upon 0.1 under the root. It means it will be equal to 1.8 into 10 to the power minus 4 into 0.1. You can solve this expression and find out the value of K, which will come out to be concentration of acetate ions will be equal to 1.8 into 10 to the power minus 2. 1.8 under the root into 10 to the power minus 2 into 0.1. On solving this expression, 1.8 under the root into 10 to the power minus 3. 1.8 under root you can find out, or you can say it will be 4.2 into 10 to the power 4.2 multiplied by 4.2. This now on solving this you will get the answer number 2, 4.2 into 10 to the power minus 2, because concentration of acetate ion will be 1.8 into 10 to the power minus 4 multiplied by 0.1 under the root. Let us see another question. 0.1 molar ammonium hydroxide has OH ion concentration 10 to the power minus 5. Then Kb for ammonium hydroxide is. Dear students, ammonium hydroxide dissociates to give ammonium ions and OH ions. So concentration of OH ions is equal to Kb into C under the root. Now he has given you concentration of hydronium ions 10 to the power minus 5. Kb we have to find out. C is 0.1. Squaring both sides. 10 to the power minus 10 is equal to Kb into 0.1. So Kb will come out to be 10 to the power minus 9. Hence the answer will be 4. Now let us move to pH. The word pH was introduced by Sorensen. It is the measure of the concentration of hydronium ions. pH is the negative logarithm of hydronium ion concentration. Dear students, if you get a choice, the best answer will be it is the negative logarithm of activity of hydronium ions. Actually, activity is molar concentration multiplied by activity coefficient.